We're going to cover in the bathroom here faucets, flush valves for the urinals and the water closets, and then we'll address the sink faucets as well. First of all, we'll start out with the urinal. Urinal wise, you're just dealing with the typical flush valve, 1 gallon per flush. This is the check stop on the Sloan flush valve for the urinals. The shutoff is underneath the safety cover on that check stop. And then this is the flush valve. Manual flush is on top, demonstrated. Power does not have to be on for the manual flush to operate. And again, that's the button there. And access into the flush valve is through unscrewing the top cover. Okay, we'll move over to the sinks now. On to the lavatories and the sensor faucets. The sensor faucets are battery operated. The sensor is located up underneath the faucet as typical. There's 2 Allen head keys that are underneath there that you're going to have to remove an access panel in order to get to the batteries, to change the batteries, which are AA batteries. Okay, here we are underneath the lavatory. You have your shutoff valves, which will require a key to operate. And then you also have your tempering valve that is underneath each individual lavatory. With the adjustment on top, there is a paper that is attached to it that is required to stay attached that will give you description as to how to increase or decrease the temperature of the water coming out of the faucet. Relatively maintenance free. You may have to take the aerator out once a year and get the lime and calcium out. Okay, and onto the water closets. What you're looking at here is actually an ADA water closet based on the size of the space that it's in. The flush valve is essentially the same flush valve as the urinal flush valve. Check stop is underneath the safety cover. Manual operation button on top. Access through removing the top cover. The difference is that the orifice inside of this is larger than that of the urinal. Therefore allowing more water to pass through to flush the water closet. We're on to the drinking fountains. This is the LK Easy H2O. You get lights for your filter status to let you know when you need to change that. You've got a sensor activated bottle filler here, and then you've got the manual activated drinking fountain traditionally as we know it. The access to this is 4 screws at the bottom of the fountain to remove the front panel. Inside there you'll find your, in this case, filter, where you're going to change your filter if it goes bad, and you'll also find the shutoff for the drinking fountain, and the compressor and all the other functions of the drinking fountain are within this panel. Okay, we moved on to the electric water heater located in the mechanical room on the 1st floor here at Scott High School. I'm going to start out with the recirculation pump. It's a Bell & Gossett, I believe it's an 8 horsepower recirc pump that feeds the hot water return back into the water heater for recirculation. Shutoff valves are attached to the flanges on either side of the recirculation pump, and your means of disconnect are located just about a foot to the left with a lighted switch here. That pipe is going to pass over into the cold water line, okay, feeding the water heater, which this is your cold feed. This is your expansion tank located here. If you're ever checking to see if this thing is bad, you can pull the cap off the top. There's a Schrader valve inside of there, and either use a pressure tester or just push it with your finger. You should have pressure inside this tank, and inside that tank is a bladder that's going to expand when the water is heated at static pressure. The water heater is basic A.O. Smith. It's a 50-gallon. Upper thermostat ECO is located behind this access panel. Access through the screw. It's your main power coming in, going into the to the heater. It's a little insulation. This thick foam is all the way around that water heater on the inside of the jacketing. There's a little safety protection to let you know that you're getting into the hot wires. Here is a reset button that can be used if the water heater were to stop functioning abruptly, or a breaker were to be tripped. It may be required to hit that reset button, and it is an effective form of restarting the water heater. This is actually the back of your upper thermostat. I'm sorry, your upper element. The thermostat is here, If you can see that little dial there is how you're going to adjust the temperature of that with a flathead screwdriver. This is the back of the upper element. The lower element looks identical to this. Simple to remove. Take the 2 leads off, shut the power off, take the 2 leads off, and take a wrench and pull that element out, and you can slide a new one in right away. Simple enough. This is your main focus if there's a problem with the water here. Upper thermostat and ECO. Energy cutoff is what ECO means. That is going to be your first place you're going to look if you have a problem with the temperature or the recovery of the water heater. Your secondary thermostat is the lower thermostat, and it is essentially a slave to the upper thermostat and ECO. So that's going to be the second step in the process to troubleshoot this if you do have a temperature increase problem. The outlet of the hot water heater comes through this line. Your temperature gauge is located here, easy to read. You're sitting at static pressure right now at about 126 to 128 degrees. Temperature and pressure valve here. There should never be any water dripping out of this. It's not a problem at all to ever come up to it and do this. And you want 2 things to happen. You want water to pass through it, and you want water to stop passing through it. If one of those 2 things doesn't happen, it's about a $15 valve that you can change, or you can have a problem with the safety of the water heater and in a potential explosion situation without this valve operating properly. It's your last line of defense. You want to be able to see that water leaking, so you go over and look at it and find out what the problem is. Okay? So it does take a couple of minutes to stop dripping when you let go of that switch. Over here, the cold water also feeds into the HVAC makeup water, and this is the start of that point. So this is our backflow preventer that we left off. Our responsibility stops at the end of that backflow preventer to the HVAC equipment. From that point on, that belongs to the HVAC contractor. We are responsible for this backflow preventer. It is piped over along the floor to the floor drain because it is not unlikely that this backflow preventer will spit water out at a quick adjustment of pressure. And that is not uncommon, and it's not a problem. So we pipe that to the drain to keep that water contained. All right, we've moved on to the art room, Scott High School. We're going to talk about the 2-bowl stainless steel sink, the Willoughby wash station behind me, and talk about the Plaster Trap as well that's on the 2-bowl sink. This is a LK 2-bowl sink. It's pretty standard, pretty simple. It's got a spray faucet as an alternate to another faucet on it. Your simple service sink, mop sink type faucet is on here. Easy to maintain. Shut-offs down below are actual ball valves, not angle stops, because they are hard piped up to the back of them. But other than that, cartridges are easy to replace and easy to find in this type of faucet. Okay, we're looking at the shut-off ball valves that are underneath the 2-bowl stainless steel sink in the art room at Scott. The 2 valves on the left are going to control the traditional faucet, which is on the left-hand side of the 2-bowl sink. And the 2 ball valves on the right-hand side are going to control the spray nozzle for the right-hand side of the 2-bowl sink in the art room. Now down here is the Plaster Trap. I'm going to run this one cold. To access the Plaster Trap, you're just simply going to take the 2 levers off. I don't even know if I needed to do that. And draw the trap up. All the sediment, as you can see, will be caught inside. So that would be rinsed out, cleaned out, and then put back in, plaster disposed of. We're on to the Willoughby wash stations here. They're set up as metering faucets for hand washing. We've added this as an extra to the wash station to rinse arms, I suppose, for the art room students. Simple operation on this. This is not going to work unless you turn the faucet on, and then you'll get whatever water you want to get out of there. There you go. Access to the Willoughby wash station comes from up here on top to adjust the metering faucets. There's 2 screws on top of the Corian here. And down below there's an access panel that wraps around the front that contains the supply shutoff valves as well as the P-trap for the Willoughby wash station. The spray faucet that has the spray nozzle, the shutoff valve for this faucet specifically are above the sink in the ceiling. They aren't underneath the Willoughby wash station. The shutoffs underneath the Willoughby wash station only shut off the Willoughby wash station. We're on to the art room sinks, not the classroom sinks, the art room sinks, and here's the difference, how deep this is. This is a very deep sink. Those are only going to be in the art room. But your traditional 8-inch spread faucet, nothing special about it. Cartridges, again, easy to find, easy to replace. And underneath, we're looking at the underside of the art room sinks, the stainless steel sinks. And you're looking at the P-trap. You'll notice that the P-traps have the clean out in the bottom of them. And then your 2 standard shutoff valves underneath there for just the sink. Nothing fantastic. These do not have tempering valves on them because they are not public access sinks. They're for the students.